Because the ball is moving to the left of the origin, the direction of the velocity is negative. Once I track the movement of the ball in Tracker, I use the data to create my computer model. I use these data points to find initial position and velocity. Initial position is the x value when time equals 0, and initial velocity can be calculated by finding the change in x values for the first few points and dividing it by the change in time. Because the velocity of the ball is constant and the ball's mass is larger than 0, I assume that the net force acting on the ball during the time period was 0. This linear model provided good predictions of what was actually observed. I plotted the data points from my observed motion and from my computer model on the same graph and compared their similarity. As you can see, my real-life data lines up almost perfectly with my computer model. Near the end of the time frame, however, the observed motion's velocity is slightly lower than that of the computer model. This can be attributed to the friction between the pool table and the ball. If we change the origin, the ball's position would be shifted in relation to the origin, but the velocity would remain the same because the change in position wouldn't be affected at all. To show this concept, I plotted my original data and data from the same video but with the origin moved away from the ball on the same graph. This graph shows that the slopes of the lines are the same. It is only the y-intercept that changes. This supports the idea that the velocity remains unchanged. Because velocity is constant and the force on the ball is 0, the total pushes and pulls on the system are also 0. While the cue stick provided the initial force, once the ball got rolling, it was no longer pushing it forward. Because there was no pushing force and the ball had a constant velocity, there was also no pulling force. Once the ball started slowing down, however, near the end of the time frame, one could infer that friction was pulling against the ball.